625 meters. That's how far you'd fall if you stepped off this bridge.
The Huajiang Canyon, in China's Guizhou province, cuts through the earth like a wound. For jet tunnel, what once demanded a 2-hour journey through treacherous mountain roads, now takes precisely 2 minutes.
"21 patents. 93 steel truss segments weighing 22,000 tons.
Before a single foundation could be poured, engineers spent months studying the canyon walls.
The geology would determine everything. Core samples drilled deep into the karst limestone revealed.
The topography demanded an asymmetrical solution. The north side would receive a gravity anchor, a massive concrete block.
Controlled explosions reshaped the mountainside. Engineers carved a V-shaped cut through solid rock, essentially splitting the
Day after day, excavator crews clawed through thousands of cubic meters of shattered rock. The gravity anchor pit alone consumed months of excavation. 160,000 cubic meters of concrete would fill
Hitterigs. Steel reinforcement bars, each 32 millimeters thick, were cut and bent to precise specifications.
Tower cranes lowered prefabricated rebar cages weighing up to 20 tons into position. On the pit floor, hold it.
Every intersection had to be tied by hand. Thousands of wire connections transformed individual bars into appearance.
Concrete pours ran around the clock. The mixture had to cure uniformly to achieve maximum strength.
The anchor design embedded cable chambers deep within the concrete mass. Like a giant hook buried in the ground, its 100
Doss withered. On the south side, rock conditions demanded a different approach. Instead of a massive block, engineers excavated a tunnel. Drill and blast methods advanced the tunnel 30 meters into the mountain. Each cycle, drill, phalanx. The completed tunnel anchor chamber represented engineering's direct conversation with geology. Steel anchor frames embeds. With the anchors complete, attention shifted to the towers themselves. The North Tower would rise 262 meters.
The Potane MCT-385 tower crane would become the project's workhorse. With a 75-meter jib and 20...
Segment by segment, the North Tower climbed skyward. A climbing formwork system rose with the structure, providing...
At 150 meters, concrete had to be pumped through lines stretching from ground level. The mixed design
Netherlands. The North Tower reached 262 meters. The South Tower stood at 205 meters.
Connecting the towers required threading a needle across 1,420 meters of empty air. A specialized drone carried the first
625 meters of nothing below. The drone battled canyon winds that could shift speed and direction without warning.
Contact, the first physical connection between towers established. This pencil-thin wire would now pull progressively heavier cables across until the full suspension system could be built.
The pilot wire pulled a 20-millimeter haul cable across the span. Each progressive cable was thicker, stronger.
Temporary catwalks extended from each tower toward the center. These narrow aluminum walkways would provide the platform for spinning them.
The moment the catwalks joined represented a milestone. For the first time, workers could walk from one side of the canyon.
Cable spinning would use the prefabricated parallel wire strand method. 217 bundles of 91 individual wires each.
Each strand traveled 2,378 meters, from anchor to tower top, across the span, down. Layer by layer, strand by strand, the main cables took shape. Each wire was 5.7 millimeters thick.
Loose strands alone couldn't support the bridge. Hydraulic compactors squeezed the bundles together, reducing air gaps and creating a unified cable.
A wrapping machine spiraled protective wire around each compacted cable at precisely controlled tension. This arm.
3 of the 217 strands contained embedded fiber optic sensors. These would monitor temperature, humidity, and stress tensions.
At each tower top, cable saddles guided the main cables over the pylons. These precisely machined steel cradles.
Cable tension had to match calculated values precisely. Too loose and the deck would sag. Too tight and thermal expansion could.
Vertical suspenders would transfer deck weight to the main cables, each clamp positioned to millimeter accuracy.
Row after row of suspenders transform the main cable into a support system. These vertical links would distribute deck weight equal.
The world's longest span cable crane system would lift the deck into place. China's fourth-generation intelligent hoistings.
Off-site, a fabrication facility manufactured the 93 steel truss segments. Specialized transporters with 96 wheels distributed each segment's massive weight across the highway.
At the bridge site, segments accumulated on assembly platforms. Virtual pre-assembly techniques had already confirmed.
Rigging a 215-ton load required engineered lift points and certified chains. Every connection checked twice. This lift-off. 215 tons rose from the earth on steel cables thinner than a human arm. Like a monorail carrying cargo rather than passengers, the cable crane trolley transported each segment to its precise position.
At mid-span, the first segment descended toward its permanent position. High-strength bolts rated for extreme loads locked the segment to the suspender cables. As the cable crane released its hold, the full width. The second segment joined the first on the north side. Building outward symmetrically from the center.
South side installation followed immediately. Alternating north and south kept forces balanced as the deck grew outward.
Every segment placement followed calculated sequence. The bridge's self-weight increased incrementally.
Canyon winds tested patience and protocols. The Venturi effect accelerated gusts through the narrow gorge. Mornings often brought calmer air. Crews learned to maximize early hours. Night operations doubled productivity when weather cooperated. Under banks of floodlights, crews worked through darkness.
Week by week, the deck reached toward the towers. Each new segment brought the promise of connection closer.
South kept pace with north. Any imbalance risked twisting forces on the cable system. Site displays tracked segment count. North 46.
80 segments airborne. The deck now carried its own substantial weight.
Tower connection segments required special engineering.
The north closure segment descended toward the final gap. Laser alignment systems guided positioning as
Norse time complete. For the first time, continuous steel linked midspan to North Tower.
January 17th, 2025. The final steel truss segment, number 93, weighing 215 tons.
the last bolt threaded home.
Mid-span celebration. Crews who had worked 3 years in conditions from freezing winter to scorching summer gathered where...
But structural completion was just the beginning of finishing work. The raw steel deck would require waterproofing, paving,
specialized bridge deck asphalt spread across the steel surface. The mixture flexed the deck's movement while providing the traction heavy vehicles demand at highway speeds.
Safety barriers would protect vehicles from the unthinkable. Concrete barriers and high-tension cables engineered to redirect
Cedars. Lighting systems combined highway illumination with decorative elements. Solar and wind hybrid power supplemented grid electricity.
Drainage scuppers would channel rainwater off the deck within seconds. Standing water at highway speeds causes hydroplaning.
This bridge would serve more than transportation. An 800-meter glass elevator climbed the tower face, carrying visitors.
A glass skywalk beneath the deck would let visitors look straight down 625 meters to the canyon floors.
Perhaps the most dramatic addition, a waterfall cascading from the deck edge. Water recycled continuously.
For those seeking ultimate thrills, a bungee jump platform. Leaping from the world's highest bridge, a 3,000 yuan ticket.
August 21st, 25. The construction was complete, but could it perform as designed?
986 trucks, each loaded to 35 tons. Over 3,300 tons of rolling weight would test this.
The first trucks rolled onto the deck. Sensors throughout the structure reported in real time. Cable tension, deck deflection.
At designated positions, the truck stopped. Over 3,000 tons pressed down on the deck. Deflection measurement. Stress distribution followed predicted patterns precisely. Static loads told only half the story. Dynamic testing, trucks crossing at speed, revealed how the bridge handled vibration and oscillation.
5 days of testing subjected the bridge to every conceivable load pattern. Day, night, calm weather.
August 25th, 2025. After 5 days of relentless testing, the certification came through.
Final preparations transformed the construction site into a public highway. Lane markings sharpened.
The scissors closed. Red ribbon fell. The Huajiang Grand Canyon Bridge.
The first public vehicles rolled onto the deck. Passengers pressed faces to windows. Cameras capturing views never.
From behind the wheel, the canyon that once blocked passage now simply passes by. Tower cables count off the meters.
Aerial view revealed the transformation complete. 4 lanes of commuter connection now flow.
The glass elevator climbed the tower face, carrying visitors skyward. Below, the canyon floor grew smooth. The glass skywalk tested nerve and trust alike. Glass engineered to hold far more than it would ever carry.
For some, watching wasn't enough. Bungee jumpers paid 3,000 yuan for what the bridge alone could offer. Water cascaded from the deck edge, falling in sheets that caught sunlight and shattered into mist far below. At nightfall, the bridge transformed again. LED systems illuminated every cable and contour. The bridge redrew the map of Guizhou. Communities once isolated by geography, now
Beyond statistics, real lives transformed. Farmers reaching markets hours faster.
The 21 patents secured during construction now inform bridge building worldwide. The 4th-generation cable crane system.
The smart cable system never sleeps. When humidity exceeds 64%, dehumidifiers activate automatically.
Rexings. Global recognition followed completion. Engineering associations documented the achievement.
Guizhou province now holds the top 3 highest bridges on Earth.
44 months compressed, from the first survey stake to the final bolt. Raw materials becoming world record.
Every bridge is built by people. Engineers who joined steel, riggers who guided loads. Dawn reveals the bridge in silence before traffic returns. The structure stands patient.
By midday, traffic flows in steady streams. Goods move to markets. Families visit relatives.
625 meters, 22,000 tons, 93 segments, 217 strands.
The Huajiang Grand Canyon Bridge stands where nature carved a barrier over millions of years.
Look closely at any bridge and you find human evidence. Welds made by specific hands.
As darkness claims the canyon, light reclaims the bridge. LED sequences reveal the structure that daylight. 625 meters above, travelers cross in minutes what once took hours. The Huajiang Grand Canyon Bridge.
World's highest.
World's longest mountain span. Dawn returns. Traffic resumes. The bridge serves. Day after day.
One vehicle, one crossing, one connection completed. Multiplied by millions of journeys over.
Inside China's canyon, above the Beipon River, 625 meters from the water to the deck.
The Huajiang Grand Canyon Bridge.
This channel exists to take you inside the world's most extreme construction projects, step by step, from the first cut to the final structure.
If you want to see how the impossible is built, subscribe now.